Hello, this is question 5 of exam 1. Question 5 asks us to solve for the integral of cosine x times cosine to the 5th power of sine x dx. So our first step here will be to do a u substitution, and we'll set it equal to sine x, and the derivative of sine x is cosine x dx. Now we'll rewrite our function using the u substitutions. We'll write the integral of cosine to the 5th power of u, and the du helps us get rid of this extra cosine x that we started off with. So times du. And then we'll rewrite this as an integral of cosine u squared, and then squared again, times cosine u. So we still have all 5 of our cosines. And then cosine squared u is also a trig function. That trig function is cosine squared theta is equal to 1 minus sine squared theta. So we'll plug this into our function so that we can work much easier with it. We get the integral of 1 minus sine squared theta, or u in this case, squared, times cosine u du. Now for our next step, we'll do another u substitution, or in this case a z substitution, and we'll set it equal to sine u, and the derivative being cosine u du. And we'll rewrite our function down here in terms of z, and we get the integral of 1 minus z squared times dz. Now this is much easier to work with than what we started with, and we'll FOIL this. So 1 minus z squared times 1 minus z squared. We FOIL, we get 1 minus z squared minus z squared. Negative times a negative is a positive, z to the 4th power. We combine our like terms to get 1 minus 2z squared plus z to the 4th power. And then we'll plug this into our function and rewrite it. So we get the integral of 1 minus 2z squared plus z to the 4th power dz. And now I'm going to expand this function just so that we know what we're doing and working with. So we get the integral of 1 dz minus the integral of 2z squared dz plus the integral of z to the 4th power dz. And now from here, these are much more easier functions to integrate on their own. So I'll start with the integral of 1 dz, which is simply z. And then in green, I'll do the integral of 2z squared dz. We bring out the constant, and we have the integral of z squared dz. And then I'll further integrate it. So we get 2 times z to the 3rd power over 3. And there's no bounds. And then I'll integrate our last. And we get the integral of z to the 4th power, or in this case, it would be z to the 5th over 5 with no bounds. Then I'll rewrite it down here, just so we have all our functions together. And now that we've fully integrated our function, we can start to plug in our substitutions once again. So z was set equal to sine u. So we'll start plugging that in first. So we have sine u minus 2 over 3 times sine u to the third power plus 1/5 times sine u to the fifth power. And now if we remember, we also substituted in a u, and u was set equal to sine x. So we'll start plugging that in as well. So our final result is sine of sine x minus 2/3 times sine to the third power time of sine x plus 1/5 times sine to the fifth power of sine x plus c. Because we didn't have any bounds, we have a constant at the end.